Unit 1. Matter and its construction. Lesson 3. Atomic structure of matter. Atom. As you can see, everything around us is formed of molecules, as we saw from our previous lesson. For example, this can consist of aluminum molecules, which are formed from aluminum atoms. These pieces of coal are formed of carbon. They are formed of carbon atoms. This piece of gold is formed of gold molecules, which are formed from gold atoms. Even air around us, it contains oxygen molecules, nitrogen molecules. Oxygen molecule is formed of 2 oxygen atoms. Nitrogen molecule is formed from 2 nitrogen atoms. Even this cleaning liquid, which is chlorine, is formed of chlorine molecules, which is formed of 2 chlorine atoms. So what's meant by atom? Atom, it is the fundamental building unit of matter, or we can say it is the basic building unit of matter. Or atom is the smallest individual unit of matter which can share in the chemical reaction. This is a real image for benzene molecules, which is magnified about 10 million times by using very powerful microscopes. Chemists use symbols which easily express the elements. Chemical symbols of elements. We have to memorize each element and its symbol. Hydrogen. Its symbol is H. Helium, He. Lithium, Li. Beryllium, Be. Boron, B. Carbon, C. Nitrogen, N. Oxygen, O. Fluorine, F. Neon, Ne. Sodium, Na. Magnesium, Mg. Aluminum, Al. Silicon, Si. Phosphorus, P. Sulfur, S. Chlorine, Cl. Argon, Ar. Potassium, K. Calcium, Ca. Iron, Fe. Copper, Cu. Zinc, Zn. Bromine, Br. Silver, Ag. Iodine, I. Gold, Au. Mercury, Hg. Lead, Pb. From the previous table we find that the symbol of any element represents only an individual atom. It represents only one atom. For example, hydrogen. H only represents one hydrogen atom. Lithium, one lithium atom. Silver, one silver atom. Potassium, one potassium atom. Sodium, one sodium atom, and so on. Also, the symbol of the element is represented by one letter and in other cases by 2 letters. If the symbol of the element was one letter, it is written in capital. For example, hydrogen, one letter and is written in capital form. Boron, one letter in capital. Carbon, one letter in capital. Nitrogen, N, one letter, capital. Oxygen, one letter, capital. If the symbol is formed from 2 letters, the first one must be written in capital and the second one in small. For example, helium, H capital E small. Lithium, L capital I small. Beryllium, B capital E small. Neon, N capital E small, and so on. Also, we note that some elements are common in their initial letters, so the second letter is taken to differentiate between them, such as carbon and calcium. Both of them starts with C, so we talk C for carbon and the first and second letters for calcium, Ca, carbon and calcium, sulfur and silicon, hydrogen and helium. The element symbol is taken from its Latin name, so that symbols of some elements differ from their names in English language. Examples: sodium. We try to take S, but it is taken for sulfur and SO for another element and SD for a third one. So sodium name in Latin language is natrium, so its symbol is Na. Scientists didn't take N because it is already taken for nitrogen, so Na. Potassium, its Latin name is kalium, so its symbol is K. Iron, its Latin name is barium, so its symbol is Fe. Copper, coparium, so its symbol is Cu. Silver, argentium, so its symbol is Ag. Not Ar because it is already taken for argon, so they took the first and third letter, so the symbol of silver is Ag. Atomic construction. We will see that the structure of atom is similar to our solar system. As you remember, our solar system consists of sun and planets which are rotating around the sun. Also, atom consists of nucleus, which is similar to sun, and electrons, which are similar to planets. And as you concluded that electrons will rotate around the nucleus. So atom consists of nucleus and electrons. Nucleus. It is the central core of the atom. This means that nucleus is found at the center of the atom. And we have a very important give reason question here. Atom contains nucleus, and nucleus is positively charged because it contains, number one, protons, which are positively charged particles, and neutrons, which are electrically neutral, uncharged, zero charged, or positive and negative in the same time. So they are neutral particles or uncharged. So the charge of nucleus is positive because it contains positive protons and neutral neutrons. What about electrons? As you can see, nucleus is found at the center of the atom and it is surrounded by electrons. The first information about electrons, they are negatively charged particles. Also, they orbit or rotate around the nucleus with very high speed. Give reason 4. The mass of the atom is concentrated in the nucleus. This is because the electron has a negligible mass, very small mass, relative to the protons or neutrons. The atom is electrically neutral in its ordinary state. This is because the number of negative electrons, which revolve around the nucleus, is equal to the number of positive protons in the nucleus. So the atom is uncharged in its ordinary state. Atomic number. We will write a small number at the lower left corner of the symbol. This number will be called atomic number. What's meant by atomic number? Atomic number, it is the number of protons in the nucleus of the atom. So atomic number equal a number of protons, and as we said in the previous question, that the atom is neutral because the number of protons is equal to the number of electrons. So atomic number equals the number of protons equals the number of electrons. So for lithium atom, it contains 3 positive protons and 3 negative electrons. Mass number. We will write a small number in the upper left corner of the symbol. This number will be called mass number. What's meant by mass number? It is the sum of the numbers of protons and neutrons in the nucleus of an atom. Mass number equal number of protons plus a number of neutrons. And the number of neutrons only equal mass number minus atomic number. So lithium contains 4 neutrons and 3 protons. 3 protons plus 4 neutrons equals 7, which is equal to the mass number. How to extract information from the symbol of element? From this symbol, we can extract 6 information. Number 1, this is the symbol of lithium atom. Li is the symbol of lithium. The second information is the number which will be written at the lower left corner is atomic number. The number which will be written at the upper left corner will be mass number. The fourth information is a number of protons is equal to atomic number. The fifth one is a number of electrons also is equal to atomic number. To get the number of neutrons, we will find the difference between the mass number and atomic number. This is the sixth and last information. Problems. If the nucleus of chlorine contains 17 protons and 18 neutrons, find the atomic number and the mass number of chlorine and how the symbol of chlorine element is written. Atomic number of chlorine is equal to number of protons, so the atomic number of chlorine is 17. Mass number equal number of protons plus a number of neutrons equals 17 plus 18 equals 35. The symbol of chlorine is Cl, and we calculated its atomic number, which is equal to 17. So we will write it in the lower left corner. We calculated its mass number, which is 35. It will be written at the upper left corner. So the symbol of chlorine is Cl1735. Another one. If the nucleus of magnesium atom contains 12 protons and its mass number is 24, find the atomic number and the number of neutrons and how the symbol of magnesium element is written. Atomic number equal number of protons equal 12. Number of neutrons is equal to mass number minus atomic number equal 24 minus 12 equal 12. The symbol of magnesium is Mg. Its atomic number is written in the lower left corner, 12. Its mass number is written in the upper left corner, which is 24. The symbol of magnesium is Mg1224. What's meant by the atomic number of potassium equals 90? We have to write only the definition of atomic number. This means that number of protons in the nucleus of potassium atom equals 19. Another question. The mass number of sodium atom equals 23. This means that the sum of the numbers of protons and neutrons in the nucleus of sodium atom equals 23. The sum of protons and neutrons in the nucleus of sodium atom equals 23. Note the following. The nucleus of hydrogen is the only nucleus that doesn't contain neutrons. This is because its mass number is equal to its atomic number is equal to 1. So 1 minus 1 equals 0. For the number of neutrons, it may be equal to the number of protons, as in case of C612, nitrogen 714, oxygen 816. Number of protons in carbon is 6, and also number of neutrons equals 6. Number of protons in nitrogen is 7. Number of neutrons is equal to 14 minus 7 equal also 7. Number of protons in oxygen is 8. Number of neutrons in oxygen is equal to 16 minus 8 also 8. So number of protons is equal to number of neutrons in some cases, and also the number of neutrons may be more than the number of protons, as in lithium 37, sodium 1123, aluminum 1327. Number of protons in lithium is 3. Number of neutrons is equal to 7 minus 3 equal 4, which is more than 3. Number of protons in sodium is 11, and the number of neutrons is equal to 23 minus 11 equals 12. Number of protons in aluminum is 13. The number of neutrons is equal to 27 minus 13 equal 14. What happens if the number of protons changes? The positive charge of the nucleus changes because the number of protons change. The atomic and mass numbers change. And finally, the element changes into another element. Let's compare between protons, neutrons, and electrons. The first point of comparison is position. Proton is found inside the nucleus. Neutron is also found inside the nucleus, while electron rotates around the nucleus. The charge of proton is positive. The charge of neutron is neutral. The charge of electron is negative. The mass of proton is very large compared to electron mass. The mass of neutron is very large also compared to the electron mass. And finally, the mass of electron is very small, negligible, compared with the mass of proton or neutron. So this is the answer of the question. Give reason for the mass of the atom is concentrated in its nucleus, because electron has negligible mass if it is compared to the masses of protons and neutrons. The movement of electrons around the nucleus. The electrons revolve around the nucleus at very high speed, as you can see from this video. During their movement, they seem to be a cloud around the nucleus. The electrons revolve around the nucleus in a number of shells or orbits, just like planets. Each shell is called energy level, as you can see from this video. What's meant by energy levels? Energy levels are imaginary regions, they are not real, around the nucleus, in which electrons move according to their energies. As you will see, we have only 7 energy levels in the heaviest known atom. So the first energy level is K, the last one is Q. The maximum number of energy level is 7, which are arranged from the nucleus according to their energies as follows. The first energy level is K, which has the least energy, followed by the second energy level L, which has energy higher than K, then M, which has higher energy than L, and so on. The seventh energy level Q, which is the last one, has the highest energy, where the energy of electron is equal to the energy of the energy level. If we have an electron in K, so its energy is equal to the energy of level K, and so on. Quantum and excited atom. Quantum, it is the amount of energy lost or gained by an electron when it transfers from one energy level to another. For example, if we have the following atom and this electron gained energy, so it will move to a higher energy level. For example, this blue one was in K, and by absorbing some energy which is called quantum, it is transferred to the higher energy level which is L. It will rotate in this higher energy level until it loses the quantum of energy again, and it will return back to its original energy level. So by losing energy, quantum of energy, electron will move from a higher energy level to a lower one. By gaining energy, by gaining quantum of energy, electron will move from a lower energy level to a higher one. What's meant by excited atom? Excited atom, it is the atom that gains a quantum of energy. For example, if this yellow electron represents an electron which is at the ground level, if it absorbed energy, which is represented by this green sphere, it will move to a higher energy level, and the atom will be called excited atom. This excited electron is represented with this red sphere. This electron will rotate in its higher energy level until it loses this quantum of energy, so it will return back to its original level, and the atom will return back to its ground state. As you can see, this is energy absorbed by electron. It will move to a higher energy level. After losing this quantum of energy, electron will return back to its ground state. Electronic configuration. The number of electrons which fill the first four energy level can be calculated from the relation 2n squared, where n is the number of energy level. For example, K is the first energy level, so we will remove n for K by 1. L is the second energy level. We'll remove n and we will put 2 in case of L, and so on. The number of electrons which saturates K, we can get the number of electrons that saturates K from the relation 2n power 2. And K is the first energy level, so 2 times 1 power 2, so K is saturated with 2 electrons. The number of electrons which saturates L can be calculated from the rule 2n squared. So 2 times 2 power 2, because L is the second energy level, equals 8 electrons. The number of electrons which saturates M equals 2n power 2 equals 2 times 3 power 2, because M is the third energy level, equals 18 electrons. So M is saturated with 18 electrons. The number of electrons which saturates N, which is the fourth energy level, equals 2 times 4 power 2, because N is the fourth energy level, equals 32 electrons. So N is saturated with 32 electrons. Give reason 4. The rule 2n power 2 is not applied to calculate the number of electrons of the energy levels higher than 4, because the atom becomes unstable if one of its energy levels contain more than 32 electrons. Now we will try to write the electronic configuration of some elements. We will take the simplest element, which is hydrogen. The symbol of hydrogen is H. Its atomic number is the number which is written at the left lower corner, which is equal to 1. Its mass number is the number which is written at the upper left corner, which is equal to 1. The number of protons is equal to atomic number, equal 1. Number of electrons is equal to number of protons, equals 1. Number of neutrons equal mass number minus atomic number equals 0. Its electronic configuration, we will draw a circle which represents nucleus. We will write letter P, which represents number of protons, and we will write beside it 1. So hydrogen nucleus contains 1 proton. We will write N, which represents the number of neutrons, and it will equal 0 because the nucleus of hydrogen doesn't contain any neutrons. We have only 1 electron. We will put it in the first energy level, which is K. So the electronic configuration for hydrogen, the energy level K contains only 1 electron. The second element is helium. Its symbol is He. Its atomic number is 2. Mass number 4. Number of protons equal atomic number equals 2. Number of electrons is equal to number of protons is equal to number of atomic number equal 2. Number of neutrons equal mass number minus atomic number equal 2. Electronic configuration. The nucleus of helium contains 2 protons and 2 neutrons, and the first energy level K contains 2 electrons. Lithium. The symbol of lithium is Li. Atomic number of lithium equal 3. Mass number 7. Number of protons 3. Number of electrons 3. Number of neutrons 7 minus 3 equal 4. Electronic configuration of lithium. Its nucleus contains 3 protons, 4 neutrons, and it contains 3 electrons which are distributed in 2 energy levels. The first energy level K will take only 2 electrons because it is saturated with 2 electrons. We have another electron. We will put it in the second energy level L. So the electronic configuration of lithium K2L1. Nitrogen. Its symbol is N. Atomic number equals 7. Mass number equal 14. Number of protons equal 7. Number of electrons equal 7. Number of neutrons equal 14 minus 7 equals 7. Electronic configuration. The nucleus of nitrogen contains 7 protons and 7 neutrons. It contains also nitrogen contains 7 electrons which are distributed in 2 energy levels. K will take 2 electrons and we have 5 more electrons. We will put them in L, so the electronic configuration of nitrogen is K2L5. 2 plus 5 equals 7. The next element is oxygen. The symbol of oxygen is O. Its atomic number equal 8. Mass number equal 16. Number of protons equal 8. Number of electrons equal 8. Number of neutrons equal 8. Electronic configuration of oxygen. The nucleus of oxygen contains 8 protons and 8 neutrons. Oxygen atom contains 8 electrons which are distributed in 2 energy levels. The first energy level K takes only 2 electrons. We have more 6 electrons. We will put them in L. So the electronic configuration of oxygen is 2 electrons in K, 6 electrons in L. The next element is neon. The symbol of neon is Ne. Its atomic number equals 10. Its mass number equals 20. The number of protons 10. Number of electrons 10. Number of neutrons equal mass number minus atomic number equal 20 minus 10 equal 10. Electronic configuration. The nucleus of neon contains 10 protons and 10 neutrons, and the neon atom contains 10 electrons, which are distributed in two energy levels. K will take only 2 electrons. We have more 8 electrons. We will put them in L. So the electronic configuration for neon atom is K contains 2 electrons, L contains 8 electrons. The next element is sodium, and the symbol of sodium is taken from its Latin name. So the symbol of sodium is Na. Its atomic number is 11, mass number is 23, number of protons is equal to atomic number equal 11, number of electrons equal to atomic number equal to number of protons equals 11, number of neutrons equal mass number minus atomic number equal 12. Electronic configuration for sodium atom. Sodium nucleus contains 11 protons, 12 neutrons, and the sodium atom contains 11 electrons, which are distributed in 3 energy levels. The first energy level K will take only 2 electrons. We have more 9 electrons. We will put only 8 electrons inside L. So we have another electron. We will put it in the third energy level M. So the electronic configuration for sodium atom is K contains 2 electrons, L contains 8 electrons, M contains only 1 electron. The next element is magnesium. The symbol of magnesium is Mg. Its atomic number is 12, mass number 24, number of protons 12, number of electrons 12, number of neutrons equal 24 minus 12 equal 12. The electronic configuration for magnesium, its nucleus contains 12 protons and 12 neutrons. While magnesium atom contains 12 electrons, which are distributed in 3 energy levels, K will take only 2 electrons, L will take 8 electrons, so we have 10 electrons, and we have to put 2 more electrons. We will put them inside M. So the electronic configuration for magnesium is K contains 2 electrons, L contains 8 electrons, M contains 2 electrons. The next element is aluminum. The symbol of aluminum is Al. Its atomic number is 13. Its mass number is 27. Number of protons is equal to 13. Number of electrons is equal to 13. Number of neutrons is equal to mass number minus atomic number equal 27 minus 13 equal 14. Electronic configuration for aluminum. Its nucleus contains 13 protons and 14 neutrons, and aluminum atom contains 13 electrons, which are distributed in 3 energy levels. K will take 2 electrons, L will take 8 electrons, M will take 3 electrons. So the electronic configuration of aluminum is K2, L8, and M3 electrons. The next element is chlorine. The symbol of chlorine is Cl. Its atomic number is equal to 17. Its mass number is equal to 35. Number of protons is equal to 17. Number of electrons is equal to 17. Number of neutrons is equal to mass number minus atomic number equal 18. Electronic configuration of chlorine. Its nucleus contains 17 protons and 18 neutrons. Chlorine atom contains 17 electrons which are distributed in 3 energy levels. K contains 2 electrons. L contains 8 electrons, so they are 10 electrons. And we have 7 more electrons. We will put them inside M. So the electronic configuration for chlorine is K2, L8, and M contains 7 electrons. The next element is argon. The symbol of argon is Ar. Its atomic number is 18. Its mass number is 40. Number of protons is equal to 18. Number of electrons is equal to 18. Number of neutrons is equal to mass number minus atomic number equals 40 minus 18 equal 22. The electronic configuration for argon is its nucleus contains 18 protons and 22 neutrons. Its argon atom contains 18 electrons which are distributed in 3 energy levels. The first energy level K takes 2, L contains 8, and M contains 8 electrons. So the electronic configuration for argon is K2, L8, and M 8 electrons. The next element is potassium. Its symbol is taken from its Latin name, which is kalium, so its symbol is K. Atomic number equals 19. Mass number equals 39. Number of protons equal 19. Number of electrons equal 19. Number of neutrons equal 39 minus 19 equal 20. Electronic configuration for potassium is its nucleus contains 19 protons and 20 neutrons, and its atom contains 19 electrons which are distributed in 4 energy levels. In electronic configuration, no energy level is allowed to take more than 8 electrons, except K, which is saturated with 2 electrons, which is still less than 8. No energy level will contain more than 8 electrons. So K will take 2, L will take 8 electrons, M will take 8 electrons, so we have 18 electrons. We have one more electron. We will put it in the 4th energy level, which is N. So the electronic configuration of potassium is K2, L8, M8, and N contains only 1 electron. The final element that we will write its electronic configuration is calcium. The symbol of calcium is Ca. Its atomic number is 20. Its mass number is 40, which is written at the top left corner of the element. Number of protons is equal to atomic number equals 20. Number of electrons is equal to number of protons is equal to atomic number equals 20. Number of neutrons equal mass number minus atomic number equal 20. The nucleus of calcium contains 20 protons and 20 neutrons. Calcium atoms contains 20 electrons which are distributed in 4 energy levels. K contains 2 electrons, L contains 8 electrons, M contains 8 electrons, and finally N contains 2 electrons. So the electronic configuration for calcium is K2, L8, M8, and finally N contains 2 electrons. What is the relation between electronic configuration and the chemical activity of elements? The chemical activity is related to the number of electrons in the outermost energy level, where if the number of electrons in the outermost energy level of an atom is less than 8 electrons, the atom is unstable or active. So this atom reacts chemically with another atom or more than one atom to produce a molecule in a stable state. Each atom enters a chemical reaction for one reason: to complete its outermost energy level. If the number of electrons in the outermost energy level of an atom equals 8 electrons, like those of inert or noble gases, so the atom will be inactive or stable. So this atom doesn't react chemically with other elements because its outermost energy level is completely filled with electrons. Give reason 4. Atoms of active elements take part in the chemical reaction to produce a stable molecules, but noble gases don't enter the chemical reaction through ordinary conditions because the outermost energy levels are completely filled with electrons. Let's compare between active gases and the inactive gases. Active gases, the outer level contains less than 8 electrons, but inactive gases, their outer level is completely filled with 8 electrons except helium, which is filled with 2 electrons because its outermost energy level is K, which is saturated with 2 electrons only. Active gases take part in chemical reactions, but inactive gases don't take part in chemical reactions in ordinary conditions. Active gases molecules are formed of two atoms. They are diatomic elements. Inactive gases molecules are formed of one atom. They are monoatomic. This is the end of lesson 3. Thanks for watching.